This is SpaceTime Series 25, Episode 124, for broadcast on the 18th of November 2022. Coming up on SpaceTime, the sharpest ever image of the universe's most massive known star. The Martian crust turns out to be more complex and evolved than previously thought. And a crippled Cygnus cargo ship docks safely to the International Space Station. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have taken their best image yet of the most massive known star in the universe. The findings, reported in the Astrophysical Journal, suggest that the upper limit on stellar masses may be a lot smaller than previously thought. The huge Wolf-Rayet star, known as R136a1, is some 196 times more massive than the Sun, with some 30 times the Sun's radius and some 4.7 million times the luminosity of the Sun, with a surface temperature of around 46,000 Kelvin. The star is located some 163,000 light-years away at the center of R136, the central concentration of stars in the NGC 2070 open star cluster in the Tarantula Nebula 30 Doradus. It's located in the Large Magellanic Cloud, a satellite galaxy orbiting our own galaxy, the Milky Way, which is easily visible in southern skies. Wolf-Rayet stars are thought to descend from spectral type O blue stars after they've lost their hydrogen envelopes through power stellar winds generated by radiation pressure to reveal an exposed helium core. The new observations were made using the 8.1-meter Gemini South telescope in Chile. The study's lead author, Vinu Kalari from the National Science Foundation, says the new research challenges science's understanding of the most massive stars and suggests they may not be as massive as previously thought. Astronomers have yet to fully understand how the most massive stars, that is more than 100 times the mass of our Sun, are formed. One especially challenging piece of the puzzle is obtaining good high-resolution observations of these giants, which typically dwell in the densely populated hearts of dust-shrouded star clusters. Giant stars also live fast and die young, burning through their fuel reserves in only a few million years. By comparison, our local star, the Sun, is less than halfway through its 12 billion-year lifespan. The combination of densely packed stars, relatively short lifespans, and vast astronomical distances makes distinguishing individual massive stars in clusters a daunting technical challenge. Previous observations suggested that R136a1 had a mass somewhere between 250 and 320 times that of the Sun. But the new observations by the Zorro instrument aboard the Gemini South telescope suggest the star may only be 170 to 230 times the Sun's mass. Mind you, that would still qualify it as the most massive known star. Astronomers determine a star's mass by comparing its observed brightness and temperature with theoretical predictions. The sharper Zorro image allowed astronomers to more accurately separate the brightness of R136a1 from its nearby stellar companions, and that led to a lower estimate of its true brightness and hence mass. The lower upper limit of the maximum mass of a star would also have implications for the origin of heavier elements in the universe. These elements are created during the cataclysmically explosive death of stars, more than 150 times the mass of the Sun, in events astronomers refer to as pair instability supernovae. If R136a1 is less massive than previously thought, the same could be true for other massive stars, and consequently pair instability supernovae might be rarer than expected. The star cluster hosting R136a1 had previously been observed using other ground-based telescopes as well as the Hubble Space Telescope, but none could obtain images sharp enough to pick out the individual star members of this open cluster. And that's where Gemini South Zorro instrument came in. It was able to surpass the resolution of previous observatories by using a technique known as speckle imaging. Speckle imaging allows ground-based telescopes to overcome much of the twinkling effect caused by Earth's atmosphere. This twinkling effect is caused by different temperature layers in the atmosphere distorting light from distant celestial objects. It's the same as trying to look at the sky from the bottom of a swimming pool. Twinkling stars may be romantic for lovers, but it is a pain for astronomical observations. And astronomers have devised a variety of approaches to dealing with atmospheric turbulence. As well as placing observatories at high, dry places with stable skies, astronomers have equipped a handful of telescopes with adaptive optics systems. These include assemblies of computer-controlled deformable mirrors and laser guide stars that can correct for atmospheric distortion. As well as adaptive optics, Gemini South counters the blurring effects of the atmosphere by taking many thousands of really short exposure images of a bright object and then carefully processing the data to cancel out almost all of this blurring. And that's what Zorro does. The individual observations captured by Zorro has exposure times of just 60 milliseconds, and 40,000 of these individual observations of the R136 cluster were captured over the course of 40 minutes. Each of these snapshots is so short that the atmosphere didn't have time to blur any of the individual exposures. And by combining all 40,000 of these exposures, the team could build up a sharp image of the cluster. When observing the red part of the visible electromagnetic spectrum, around 832 nanometers, the Zorro instrument on Gemini South had an image resolution of about 30 milliarc seconds. And that's a slightly better resolution than the James Webb Space Telescope and about 3 times sharper than Hubble at the same wavelength. The result shows that given the right conditions, an 8.1 metre telescope pushed to its absolute limits can rival not only Hubble when it comes to angular resolution, but also the James Webb. While R136A might be the most massive known star, it's not the largest. That honour goes to UY Scuti, a variable hypergiant with a radius around 1,700 times that of the Sun, and with enough volume to fit almost 5 billion suns inside it. UY Scuti lies near the centre of the Milky Way galaxy, roughly 9,500 light-years away in the constellation Scutum. Hypergiants are old bloated stars near the ends of their lives. They're larger than supergiants and giant stars, but less dense than main sequence stars. So, although physically humongous in size, UY Scuti only has about 30 times the mass of the Sun, and they continually lose much of this mass through their fast-moving stellar winds. This is SpaceTime. Still to come, scientists find the Martian crust is far more complex and evolved than previously thought, and a crippled Cygnus cargo ship successfully docks with the International Space Station. All that and more still to come on SpaceTime. A new study claims the early Martian crust may be more complex and evolved than previously thought, and it may even be very similar to the Earth's original crust. The Martian surface is uniformly basaltic. That's a product of billions of years of volcanism and flowing lava on the surface, which eventually cooled and solidified in place. Because Mars hasn't undergone full-scale surface remodeling, like the constant convection of the tectonic plates through mid-ocean spreading seen on Earth, scientists thought Mars's crustal history would be relatively simple. But a new study in the journal Geophysical Research Letters has found locations on the red planet's southern hemisphere with far greater concentrations of silicon than what had been expected for a purely basaltic setting. The silica concentrations had been exposed by space rocks which slammed into Mars, excavating material that had been embedded kilometres below the surface and revealing a hidden past. The study's lead author, Valerie Payre from the University of Iowa, says there's more silica in the composition, and that makes the rocks more evolved in composition. And that tells scientists how the crust formed on Mars is definitely more complex than previously thought. Scientists believe that Mars formed around 4.5 billion years ago. But exactly how the red planet came into being still remains somewhat of a mystery. It's generally thought planets form through accretion. Rocks come together by their common gravity and gradually build up over time. As more and more rocks collide, it generates intense heat, and this heat's thought to initially entirely liquefy the protoplanet, causing differentiation. Heavier elements sinking towards the core and lighter elements floating on the surface. The result is an entirely liquefied state known as a magma ocean. Over time, this magma ocean gradually cooled, yielding a crust-like layer of skin that would be singularly basaltic. But another theory is that the magma ocean was not all-encompassing, that some parts of the first crust on Mars had a different origin, one that would show silica concentrations different from basaltic. Perry and colleagues analysed data from NASA's Mars Reconnaissance Orbiter spacecraft looking at the planet's southern hemisphere. Previous research had already indicated that this was the planet's oldest region. Researchers found 9 locations, such as craters and fractures in terrain, which were rich in feldspar, a mineral associated with lava flows that are more silicon-based than basaltic. Adding further credence to their observations, meteorites such as Ergchek 002 discovered in the Sahara and dating roughly from the birth of the solar system 4.6 billion years ago show similar silicon and other mineral compositions which the authors observed at the 9 locations on Mars. The researchers also dated the crust to about 4.2 billion years, which would make it the oldest crust found on Mars at that time. Perry says rovers on the surface of Mars have observed rocks which are more silicon than basaltic, but scientists still don't know how the early crust was formed, or how old it is, so the mystery remains. But while the origin of the red planet's crust remains shrouded, Earth's crustal history is even less clear. That's because any vestiges of our planet's original crust have long been erased due to the shifting of the continental plates over billions of years. So, new findings about the red planet's original crust may offer fresh insights into Earth's origins as well. This is SpaceTime. Still to come, a crippled Cygnus cargo ship successfully docks with the International Space Station, tracking 30 years of sea level rise. And later in the science report, it now seems almost 60% of the world's population has been exposed to either COVID-19 or the COVID vaccine. All that and more still to come on SpaceTime. A crippled Northrop Grumman Cygnus cargo ship has safely made it to the International Space Station despite only having one of its 2 solar arrays unfurling to power the systems aboard the spacecraft. The Cygnus CRS-18 cargo ship had launched 2 days earlier aboard a Northrop Grumman Antares rocket from NASA's Wallops Island Flight Facility on the Virginian mid-Atlantic coast.
T-minus 10. 5, 4, 3, 2, 1. Engine ignition.
We have liftoff. We have carried NG-18 launch vehicle on flight.
We have liftoff of Northrop Grumman's 18th Commercial Resupply Services mission. The SS Sally Ride has begun its journey to the International Space Station. The first stage is performing nominally so far.
Operating steadily at 100% thrust. Nominal. Or pressurization valves functioning as expected. Vehicle remains nominal.
1 minute into the flight, no issues are being tracked with the Antares rocket.
Passing through max Q. Vehicle remains nominal.
Antares is passing through max Q, the area of maximum dynamic pressure on the rocket.
Power remains nominal. Passing through 50,000 feet. Attitude remains nominal. Passing through 5,000 feet per second. Core pressurization valves continue to function as expected. Engines remain nominal at 100% thrust. Approximately 100 seconds to MECO. Passing through 100,000 feet. Power remains nominal.
Now at the 2-minute mark, everything is going as planned. You're hearing the Wallops Range Control Center reporting a good flight of the Antares rocket.
Nominal attitude. Core pressurization valves continue to function nominal. We have begun slow throttle down.
Throttle down is the precursor to main engine cutoff. MECO occurs at the 3-minute 18-second mark of the flight, followed right after by first stage separation. Coming up at the 3-minute mark, just seconds away from main engine cutoff.
Main engine cutoff. Stage 1 separation.
First stage separation confirmed from Wallops' Range Control Center, just as planned, about 6 seconds after main engine cutoff. Less than 20 seconds to go until fairing separation to unveil the Cygnus cargo spacecraft.
Good engine performance on stage 1. Stage 2 ignition in approximately 10 seconds. We have fairing separation.
Fairing separation is confirmed. Cygnus is now outside of its protective shell and is continuing to climb into its preliminary orbit.
We have stage 2 ignition.
And with stage 2 ignition, the second stage engine will burn for about 2 minutes, 46 seconds.
Stage 2 Castor 30XL motor will burn for approximately 2.5 minutes. Attitude remains nominal. Stage 2 TVC is nominal. Electrical power remains nominal. Attitude is nominal.
Coming up on the 5-minute mark of the flight, with second stage burnout expected at the 6-minute 53-second mark of the flight. At the time of second stage burnout and orbital insertion, Cygnus will be at an orbital altitude of 109.5 miles or 176.2 kilometers.
Stage 2 TVC is nominal power. Attitude remains nominal.
6 minutes into the flight of Northrop Grumman's Antares rocket, under a minute now until stage 2 burnout and orbital insertion. Coming up on stage 2 burnout.
We have stage 2 burnout, getting reorientation for payload separation. We have good insertion. Antares is currently in orbit and will coast for approximately 100 seconds prior to payload separation.
Cygnus has reached its preliminary orbit insertion. Next, we'll be looking for Cygnus to separate from the second stage, which will occur at 8 minutes and 52 seconds after liftoff, about 2 minutes from now.
Antares power remains nominal.
We're continuing to hear good callouts across the board. Everything is nominal at this stage of the flight.
Approximately 60 seconds from payload separation. Vehicle attitude remains nominal. Vehicle power remains nominal.
Now, 8 minutes into the flight, Antares continues to perform nominally to put the SS Sally Ride Cygnus on its way to the International Space Station. Spacecraft separation is expected in less than 1 minute.
Power remains. Antares remains nominal. And we have payload separation of the Cygnus spacecraft.
Spacecraft separation is confirmed. Antares launched at 4:32:42 a.m. Central Time, 5:32 a.m. Eastern, at the end half of the launch window. At the time of launch, the International Space Station was flying over the Indian Ocean southwest of Australia.
Okay, launch team, let's maintain our discipline, close out the pad, proceed with our post-launch checklist. Step 448, Prop 1.
Range Control Center at NASA's Wallops Flight Facility. Cygnus has successfully separated from the second stage of the Antares rocket, and at this time, operations of the vehicle will move to Dulles, Virginia, under the direction of Northrop Grumman's Cygnus flight controllers. The SS Sally Ride has successfully moved through its milestones to get it into its preliminary orbit. It will spend the next 2 days catching up with the space station for a rendezvous and capture, followed by the installation of the vehicle to the Earth-facing port on the Unity module. Cygnus is carrying 8,200 pounds of scientific experiments, food, hardware, and supplies to the people living aboard the International Space Station. We highlighted a couple of the scientific experiments on board, but this Cygnus is also carrying a number of tools as well as hardware that our spacewalkers might use in future spacewalks.
Once safely in orbit, Cygnus deploys its antennas for communications and navigation and its twin solar arrays, which provide auxiliary power for all onboard systems. However, on this occasion, only one of the solar panels unfurled as designed. Flight controllers tried in vain to open the stuck panel. Luckily, enough power was being generated by the remaining array to feed all the spacecraft systems, and so it was decided to allow the mission to proceed. The space station's robotic arm was used to grab the spacecraft 2 days later and maneuver it into the Earth-facing port of the Unity module. It's the 18th Cygnus cargo supply mission to the orbiting outpost. On board was 3,700 kilograms of cargo, including science and research equipment, spacecraft hardware, as well as lots of food, including apples, blueberries, cheese, peanut butter, and cream cheese for the station's American, Russian, and Japanese crew members. Cygnus also delivered a new mounting bracket, which astronauts will attach to the starboard side of the space station's truss assembly during a spacewalk to install new solar arrays. The mission also delivered a number of CubeSats that will be deployed later from the space station. These include Pearl Africa Sat-1, the first satellite developed by Uganda, and Zimbabwe's first satellite ZimSat-1, as well as the Japanese Takaka satellite. The science equipment aboard the resupply mission will support dozens of the more than 250 investigations currently being conducted by Expedition 68. These include a biofabrication facility designed to print biological tissue in microgravity, an experiment to see how plant genes turn on and off when exposed to spaceflight, that's part of research to improve plant growth in microgravity, a post-wildfire mudflow microstructure experiment which will evaluate the composition of mudflows, including sand, water, and trapped air, in order to better understand fundamental mechanisms that govern wildfire debris movement. And fertility studies to examine how microgravity affects living cell cultures. The Cygnus will remain docked to the space station until January, where, once emptied of supplies, it'll be used as a garbage receptacle and eventually be disposed of through destructive re-entry into Earth's atmosphere. 30 years ago, scientists and engineers launched a new satellite, TOPEX Poseidon, to study the rising and falling of the planet's sea levels over time. It was a task which previously had only ever been done from the coast. The observations confirmed on a global scale what scientists previously saw from the seashore, namely that seas are slowly but gradually rising, and that pace of sea level rise is accelerating. Scientists have found that average global mean sea levels have risen by 10.1 centimetres since 1992. Over the past 140 years, satellites and tide gauges together show that global sea levels have risen between 21 and 24 centimetres. Starting with TOPEX Poseidon, NASA and various partner space agencies have flown a continuous series of satellites that use radar altimeters to monitor ocean surface topography. Essentially, it's the vertical shape and height of the oceans. Radar altimeters are incredibly reliable. They continuously send out a pulse of radio waves in microwaves that reflect off the ocean's surface and back to the satellite. The satellite's at a constant altitude above the center of the planet. The instruments can then calculate the time it takes from the signal to return to the spacecraft, while also tracking the precise location of the satellite in space. From this, scientists derive the exact height of the sea surface directly underneath the satellite. Since 1992, 5 missions, all using similar altimeters, have repeated the same orbit every 10 days. There was TOPEX Poseidon between 1992 and 2006. In 2001, the Jason-1 spacecraft was launched, operating until 2013. The Ocean Surface Topography Mission Jason-2 spacecraft was launched in 2008, and it flew to 2019. Jason-3 was launched in 2016, and it's still operating up there. And the new joint NASA-European Space Agency Sentinel-6 spacecraft was launched in 2020. Sentinel-6 oceanographer Josh Willis from NASA's Jet Propulsion Laboratory in Pasadena, California, says that with 30 years of data behind them, scientists can finally see exactly what sort of a huge impact humans are having on the Earth's climate. The rise of sea levels caused by human interference with the climate now dwarfs natural cycles. And it's happening faster and faster every decade. The altimetry data shows that the rate of sea level rise is accelerating. Over the course of the 20th century, global mean sea levels rose by 1.5 millimetres per year. But by the early 1990s, it was about 2.5 millimetres a year. And over the past decade, that rate has increased to 3.9 millimetres annually. Now, while a few millimetres of sea level rise every year may seem small, scientists estimate that every 2.5 centimetres of sea level rise translates to 2.5 metres of beachfront that's lost along the average coastline. It also means that high tides from storm surges will reach even higher, bringing more coastal flooding even on sunny days. This report from NASA TV.
Spend a few minutes on any beach and you'll realize just how much the ocean can transform the shoreline. I'm Josh Willis, project scientist for the Sentinel-6 Michael Freilich satellite, a new Earth-observing satellite that will give us the ability to track and understand sea level rise like never before. It will extend the record of sea level rise another decade past the 30 years we already have and allow us to see how sea level is not only rising, but how it's accelerating. This has huge consequences for the planet because sea level rise is one of the most important consequences of human-caused global warming. Sea levels are rising at a faster and faster rate every decade. We need these measurements to help us predict how quickly flooding will increase across the planet. Sentinel-6 will also bring us higher resolution measurements of sea level, which is incredibly important near the coastline where currents are narrow and changes can be difficult to observe from space.
Currents in the ocean tilt the sea surface, making sea level high on one side and low on the other. Also, warm water stands taller than cold, so sea level measurements tell us about both ocean currents and ocean heat.
Ocean currents affect our daily lives because the ocean has a strong impact on climate. The Pacific Ocean strongly determines droughts and rainfall. Hurricane forecasting uses satellite altimetry to help predict how much hurricanes will intensify. Ocean conditions can change quickly, and forecasters need data in near real time to predict how currents and marine weather will change across the globe.
This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. New research has shown that rapid rainbursts have intensified over Australia's largest city by 40% in the last 2 decades. The findings, reported in the journal Science, are based on new techniques using weather radar data to identify rapid rainbursts. Rapid rainbursts, also referred to as sub-hourly heavy rainfall, are destructive short bursts of rain that can overwhelm roads, gutters and drainage systems in as little as 10 minutes, often causing flash flooding. Utilising weather radar data over Sydney and overlapping radars over Newcastle to the north and Wollongong to the south, scientists identified a 40% increase in the intensity of rapid rainbursts over the past 20 years. Previous studies of climate impacts on extreme precipitation have focused mainly on daily rain totals. But hourly extremes are often generated in small areas that can be missed by gauge networks or satellites and are not accounted for in climate models. The authors warn that further research is urgently needed to equip cities worldwide for the likelihood of more rapid rain bursts in the future. Even in places with little trend in daily rainfall extremes, there may be increased risks of flash flooding if the intensification of the sub-hourly rainfall extremes continues. A new report in the journal PLOS One claims that some 59.2% of the world's population has now been exposed either to COVID-19 or a COVID-19 vaccine, or both. Official COVID-19 infection rates, which rely on testing, can miss cases due to factors including a lack of tests and infections without symptoms. To try and fill in these gaps, the study's authors compiled and analysed studies across the world that tested populations for COVID-19 antibodies, which indicates someone has either had COVID-19 or has been successfully vaccinated. The researchers say antibodies were detected in 59.2% of people by September 2021. That's up from just 7.7% in June 2020. More than 6.6 million people have now been killed by the COVID-19 coronavirus since it was first detected near China's Wuhan Institute of Virology around September 2019. However, the World Health Organization says the true death toll is likely to be over 15 million, with some 640 million confirmed cases globally. While the Lancet Commission, a panel of world-leading experts in policy and disease management, estimates around 18 million people have now actually died because of COVID-19. A new native bee species with a dog-like snout has been discovered in bushland around Perth. The research by scientists from Curtin University sheds new light on our most important pollinators. The study's author, Kit Pendergast, has named the new species after a pet dog, Zephyr, after noticing a protruding part of the insect's face looks similar to a dog's snout, and to acknowledge the role her dog played in providing emotional support during a PhD. Pendergast says the rare and remarkable discovery adds to existing knowledge about our evolving biodiversity and ensures the bees are protected by conservation efforts. There's a warning today about the latest pseudo-scientific practice to do the rounds and try and attract new clients. It's called Neuro-Emotional Technique, or NET. It's a bizarre mixture of different alternative medicine practices, including chiropractic, acupuncture, and applied kinesiology. Scientific studies and case reports meant to show potential clients the benefits of this new treatment are usually not true peer-reviewed scientific papers, with many being little more than the practitioner describing how they used this treatment on a client and how the problem then went away. The studies are very small, and they're mostly either unblinded or only single-blinded. There were either no controls and no detailed description of how the treatment physiologically altered the initial condition, or when there were control groups, they weren't properly monitored. Several of the papers listed as studies didn't actually examine how the treatment was meant to work, providing no scientific evidence at all. Tim Minham from Australian Skeptics says the true goal of Neuro-Emotional Technique, or NET, is to expand chiropractic's scope of practice using chiropractic manipulations, applied kinesiology, and traditional Chinese medicine techniques.
Neuro-emotional technique is something fairly new. It's put out by a particular chiropractor, and it's drawing on different a bit of an amalgam of different alt med methodologies. You like chiropractic is one, acupuncture is another, applied kinesiology is another, and you throw in a bit of psychotherapy at the same time. Basically, it's based around you are stressed. This is part of the psychotherapy side. So you are stressed, you've had a trauma, and that's affecting your health. Now, obviously, trauma is going to affect your health. But the way that this is assessed is by getting you to talk about your trauma, we do therapy, getting you to put your palm on your forehead, which is obviously your brain, and then you can talk to your muscles and talk to your illness, and you'll then find out where it is. And then once the chiropractor / acupuncturist / applied kinesiologists then they manipulate or touch your muscles and they find sensitive spots, and then they can sort of basically talk the stress away. And it might only take about 50 visits, right? It's obviously instantaneous, and funny that, it'll take about 50 visits to get rid of this stress based on a particular event from way back when. So chiropractic, it has benefits sort of in back pain massage. Forget the supposed underpinnings of that, what chiropractic's supposed to be, subluxations and all this sort of stuff, which has never been proven to even exist, let alone have an impact on you. Acupuncture, sticking needles might have interesting effects. The meridian idea is old, based on Chinese rivers, I think. Actually, you map out a Chinese river and you map out a similar thing on your body.
Yeah, it's totally garbage, of course.
Yeah. And applied kinesiology is totally silly. Kinesiology is a legitimate science about the study of movement, especially body movement, but applied kinesiology is playing games, party tricks, really, and we have investigated it, show that it's party tricks of being able to put you off balance and this sort of stuff, and it really has no bearing on anything. So you then throw in the psychotherapy, which itself has problems, and combine them all. And the nice thing is, of course, it gives the chiropractor a bit more avenues to promote their wares. So this is something new. It's not widely practiced. It's being promoted. And the interesting thing is a whole range of scientific papers supposedly put out. Most of these scientific papers are junk. They're all coming out from one source. One scientific paper they didn't include in this one group was one that actually showed there was nothing there. Funny that. But it's putting pressure on the patient to talk about their stress, which is not a great thing to do, especially if the stress doesn't actually exist, or if it certainly cannot be treated in the way that they claim it can be treated.
Unless you're a trained psychologist or psychiatrist, you shouldn't even be doing that.
Yeah. Throwing a chiropractic, acupuncture, and applied kinesiology into the mix it means you've got a bit of mumbo jumbo, a bit of moving the hands, and sort of looking like you're doing something more than just talking to the patient. And if you can bring them back dozens of times for more treatments, it's good business. It's mumbo jumbo, mixing up mumbo jumbo, a lot of it, and the end result is mumbo jumbo, not sort of some better sort of scientific regimen. The thing to watch out for, it's NET. It's something to watch out for, something that's being promoted to basically increase the range of treatments that chiropractors can give. Chiropractors are not exactly trained in psychiatry or psychotherapy, but it's a thing that's been promoted actually by two universities. One is Macquarie University in Sydney, and some time ago Macquarie University was trying to get rid of its chiropractic courses and things, its department, sell it off to a different university in a way, but then they kept it on.
Someone gave them a grant, did they?
Something like that, or perhaps they thought there was enough students out there to make it worthwhile. Forget how effective it is. Just is there a business case for it? So they did keep it on, but we had the feeling that other medical faculties within the university weren't too keen to have it there. And now if they're spreading this neuro-emotional technique, this sort of elaboration on it and mixing it in with other things as well, you wonder how the established evidence-based medical practitioners and academics in that university might be getting worried.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @Spacetime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/Spacetime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.